Imagine a world, maybe just 10 years ago or so, where all those fantastical promises of artificial intelligence suddenly started popping up everywhere. Not in some sci-fi movie, but, in our hospitals, how we talk to each other, even making art. It wasn't this slow academic thing anymore. By the mid-2010s, it really felt like an
Oh,
explosion.
yeah, it's quite a shift, a sudden surge almost.
Exactly. So today, we're doing a deep dive into what we're calling AI in the wild. We want to explore that pivotal moment when deep learning, well, it basically escaped the lab. And it started this messy, sometimes amazing, sometimes really problematic journey into the real world.
Mhm.
We'll trace how it impacted medicine, language, creativity, looking at the big successes, the humbling failures,
Hmm.
and what it all really tells us about this technology.
What it actually is
Yeah.
underneath the hype.
Our mission, really, for you listening, is to get a handle on how these neural networks started changing things in high-stakes areas. Think diagnosing diseases, global communication, even art. We'll pull out the surprising bits, the critical insights from the sources we've looked at, giving you a shortcut to understanding this really fascinating era of AI sort of coming of age.
And we have looked at quite a stack. We've got foundational stuff like deep learning and artificial intelligence, a modern approach, but also more critical views, things like AI snake oil and Atlas of AI,
Yeah.
plus some forward-looking perspectives, AI 2041, brave new words, co-intelligence. So yeah, a real mix.
That breadth is good, lets you see it from different angles.
Exactly, gives you a more nuanced picture of what was happening.
Okay, let's unpack this then. The mid-2010s, it really felt like a turning point. Before that, AI felt, well, more theoretical, right? Stuck in academia. What exactly shifted? What made deep learning suddenly seem so, I don't know, applicable in the real world? It wasn't just theory anymore.
It's a great question. And what's fascinating is, like you said, the groundwork was laid much, much earlier.
Yeah.
But several things just kind of clicked together around that time.
Yeah.
You take someone like Geoffrey Hinton, often called a godfather of AI. He was really instrumental. Back in the 80s, actually, he and some colleagues figured out how to use this technique, backpropagation.
Backpropagation, right. I've heard that.
Yeah, exactly. And they used it to effectively train these multi-layered neural networks. Later, he sort of rebranded the whole concept as deep learning.
Mm.
And it wasn't just a name change, It reflected this newfound ability to actually train networks with multiple hidden layers. That was the breakthrough.
Hidden layers, so more complex structures.
Right. See, the early neural nets were pretty simple, often just like a single layer of these processing units, these neurons.
Yeah.
The challenge was always, how do you get them to learn really complex stuff? The intuition was, well, stack more layers, make them deep.
Hence the name.
Precisely. The deep in deep learning is literally about having these multiple connected layers, trying to mimic the brain structure a bit more. But for decades, training these deeper networks was, well, it was incredibly difficult. Imagine trying to teach someone something complex, but you only tell them if their final answer is right or wrong.
Without telling them where they went wrong in the process.
Exactly. The learning signal just wouldn't get through effectively to the earlier layers. It was slow, inefficient, just didn't work well for deep networks.
So it wasn't just about having more layers, but finally finding a way to, teach them effectively, give them feedback deep down.
That's it, exactly. And that's where backpropagation came in. It was the crucial algorithm. Think of it like, okay, the student takes a really hard math test, they get an answer wrong. Backpropagation isn't just the teacher saying, nope, wrong. It's like the teacher meticulously going back through every single step the student took.
Finding the specific mistake.
Finding the mistake. Yeah, and figuring out how much each step contributed to that final error. Then it adjusts the connections, the sort of strength between the neurons working backwards through the network, layer by layer. It's this dynamic adjustment based on the errors that allowed these deep networks to actually learn, to process information across all those layers much more effectively than before. It cracked the problem that had held back deep networks for so long.
That makes so much sense. A feedback loop that could actually reach down and fix things deep inside. That sounds like a total game changer. But were there other pieces, like the actual building blocks, the computations? Did other things have to happen too?
Oh, absolutely. You needed more than just backpropagation. The source deep learning points out that just empirically, having greater depth, more layers, consistently led to better generalization.
Generalization meaning it could learn from one thing and apply it to something new it hadn't seen before.
Exactly. Not just memorizing the training data, but actually learning underlying patterns. And key algorithmic components were also vital. For instance, something called the ReLU activation function became super important.
ReLU, rectified linear unit. Sounds pretty technical. Can you break that down a bit? What does ReLU do for the learning?
Sure. Um, okay, imagine you're trying to draw a really complex curve, but all you have is a ruler to draw straight lines. You can approximate it, but it's not great, right?
Right, you lose all the smooth bits.
Exactly. ReLU basically gave the network the ability to introduce nonlinearity. It allowed it to learn more complex, curvy relationships in the data. Before ReLU, many activation functions had this issue called the vanishing gradient problem. The learning signal would just get weaker and weaker as it went back through the layers.
Ah, so the feedback wouldn't even reach the early layers in deep networks.
Pretty much. It made training deep networks incredibly hard. ReLU helped fix that. It lets the signal pass through strongly when it's positive, but shuts off when it's negative. Simple idea, but really powerful. It was crucial for learning the messy, complex patterns you see in the real world, things that aren't just straight lines. And technically, it helped make the math work for the training methods, the gradient descent. Without things like ReLU, deep learning just wouldn't have scaled.
Okay, so it wasn't just more layers or just better teaching with backpropagation. It was also about giving those layers the right internal tools to actually represent complex information. It sounds like this whole period, the mid-2010s, wasn't just incremental improvements. It was more like a fundamental shift in understanding how to build these things.
It really was a paradigm shift. This period showed that this core belief was incredibly powerful. The idea that the complex things AI needs to learn can be broken down into simpler steps, like computer programs made of multiple stages where each stage builds on the last. You get this hierarchical learning, this abstraction. The big insight wasn't just, hey, we made AI better. It was realizing that by building intelligence this way, layer by layer, we sort of stumbled onto a general purpose technology.
General purpose, meaning it could be applied almost anywhere.
Exactly. It hinted at this huge potential for AI to be useful across tons of different domains, way beyond what people had thought. That architectural insight, plus the algorithms like ReLU, plus suddenly having way more computing power and massive data sets, that was the perfect storm.
That really clarifies how deep learning kind of broke out of the lab. But the moment that really shook things up, the one everyone noticed, was when this power got applied to real-world stuff, especially areas where mistakes really, really matter. And I can't think of many places with higher stakes than medicine. So where did it go first? How did it start impacting healthcare?
Yeah, if you connect this to the bigger picture, medicine was an immediate and incredibly impactful place for it to land. Deep learning is fundamentally good at pattern recognition, right?
Right. Seeing things humans might miss.
Exactly. So it was perfect for tasks that were super time-consuming, or maybe error-prone for humans, or just incredibly expensive. It offered this promise of speeding up research, making diagnoses better, real hope for tackling some major health challenges. One of the really compelling early uses was in drug discovery. That process is traditionally so slow, so painstaking, unbelievably costly. Years and billions of dollars for one drug.
Just sifting through possibilities, right?
Yeah, sifting through countless molecules to find one that might actually work against the specific disease protein. So companies like Atomwise, mentioned in prediction machines, popped up. They used AI specifically for this. Their main thing was an AI tool designed to predict binding affinity, basically how strongly a potential drug molecule will stick to the target protein you care about. And they built up these unique data sets, information on disease proteins, how molecules bind to give their AI a huge library to learn from.
So that prediction part, figuring out which molecules might stick, that's usually a massive bottleneck, isn't it? Lots of lab work, trial and error.
Huge bottleneck. AI could essentially take over that initial super time-consuming prediction task instead of chemists spending months or years physically making and testing compounds in the lab.
The AI could screen millions virtually.
Exactly, in days, maybe even hours. It could rapidly scan these vast virtual libraries of molecules and just spit out a list of the most promising candidates. This freed up the human experts, the scientists, to use their judgment on the strategic questions. Like, okay, this molecule binds well, but what about side effects? Can we actually manufacture it easily? It let humans focus higher up the chain.
That really shows AI acting as a kind of prediction machine, like the source says, making one critical step way cheaper and faster.
Precisely. And that acceleration became incredibly relevant, obviously, during things like the COVID-19 pandemic. Suddenly, speed in finding treatments was everything. And it wasn't just drug discovery. Deep learning made huge strides in things like cancer detection and also predicting protein structures. There's a mention of work by Senior and colleagues on protein structure prediction. That has direct implications for understanding diseases, including cancer.
How so? Protein structure. That sounds
Yeah.
fundamental.
It is. Proteins are like the little machines in our cells, doing almost everything. Their function depends entirely on how they fold into these complex 3D shapes. If they misfold,
Yeah.
you can get diseases like Alzheimer's, Parkinson's, many cancers. Predicting that 3D shape just from the sequence of amino acids, that was a massive challenge in biology for decades.
And AI could do it.
AI got incredibly good at it.
Yeah.
It could also analyze complex medical images, like scans, spotting subtle patterns of disease that a human radiologist might miss, or model those protein folds accurately. This opened up totally new ways to design targeted treatments.
So for you listening, what does this actually mean? Faster breakthroughs, better treatments.
Yeah, fundamentally, it pointed towards medical breakthroughs happening faster, new drugs developed more quickly, diseases caught earlier, diagnosed more accurately, and treatments becoming more personalized. Moving away from this one-size-fits-all approach towards therapies tailored to your specific biology, it really has the potential to impact health outcomes globally, making medicine more proactive, more predictive. We also saw AI getting woven into just, practical clinical settings, automating routine but important tasks. AI 2041 gives this scenario. Imagine automated body temperature checks. Like someone walks through a checkpoint, and if their temperature is high, glowing arrows on the floor automatically guide them to a separate risk channel.
Ah, like for fever screening during an outbreak. Very practical.
Exactly. It's managing public health in real time. It shows how AI can automate these routine checks, cut down on human contact points, triage people efficiently, increases safety, makes things run smoother, especially in busy places or during, pandemics.
It's like an invisible layer of management.
Kind of, yeah. An invisible guardian, automating that first line of detection and routing, freeing up the humans for the more complex cases.
Okay, so from these really personal, high-stakes medical applications, let's shift to something equally complex, global communication. How did AI start changing how we understand each other across different languages? That seems like a massive hurdle full of nuance.
It is remarkable, isn't it? Tackling human language so ambiguous, so context-dependent, and it immediately brings up this big question. What does it actually mean to understand language? For a human or for a machine, how do you even measure that? Deep learning completely revolutionized machine translation. Think Google Translate. Before the mid-2010s, those tools were pretty clunky, right?
Yeah, often comical. You'd get nonsense back.
Exactly. Very literal, word for word. They struggled badly with context, idioms, different sentence structures. The output was often just grammatically weird or missed the meaning entirely. Then came these new architectures. Deep learning, the book, talks about encoder-decoder sequence-to-sequence models. Yeah. These were key for certain types of neural networks, RNNs, to handle mapping an input sequence, like a sentence in French.
To an output sequence, like the same sentence in English.
Right, but crucially, sequences of different lengths. That capability was absolutely essential for translation, but also for speech recognition, question answering, lots of language tasks.
So if I'm getting this, it wasn't just word for word anymore. It could grasp the meaning of a whole phrase or sentence, no matter how long, and then express that meaning in another language, even if the grammar or sentence structure was totally different. That feels like a huge leap.
You've nailed it. That was the leap. Deep learning allowed for this much more fluid, context-aware translation. It went beyond just substituting words to actually capturing more of the intended meaning. Think about translating German, where the verb often hangs out at the end of the sentence. Older systems choked on that. These encoder-decoder models could process the entire German sentence, figure out the core meaning, and then generate a natural-sounding English sentence with the verb in the right place.
So it understands the whole thought, not just the pieces.
It processes the whole input sequence before generating the output sequence. This ability to handle varying lengths, different structures, that was the massive technical and conceptual jump. It's why translation tools today feel so much better, making global communication genuinely easier. But, and this is a big but, this amazing technical feat also really threw a spotlight on a deeper philosophical question about meaning. The book Gödel, Escher, Bach makes this point brilliantly. It says just producing the right sounds in another language is hardly worthwhile unless those sounds actually create the intended effect in the listener's brain. Analogous emotional responses to what a native speaker would feel.
Whoa, that's deep. So is the AI really getting the poetry, the subtext, the feeling, or is it just an incredibly sophisticated mimic? Simulation versus actual understanding?
That's the core philosophical challenge. Is the AI truly deciphering meaning like a human does? Or is it just doing incredibly advanced pattern matching based on all the text it's seen? GB uses the analogy of an alien civilization encountering human music. Would just reproducing the sounds count as understanding? Or would they need to somehow make sense out of the sound, activating similar structures in their alien brains?
A huge difference.
Profound difference, yeah. Between computational fluency, being good at processing and generating language, and genuine semantic understanding or subjective experience. That's still the hallmark of human cognition. The takeaway is AI's gotten amazing at mimicking human language, but whether it understands it like we do, that's still a huge, maybe unanswerable question.
And for you listening, you might use Google Translate every day, maybe for travel, maybe for work. But have you ever paused to think, does this thing really get what I'm saying? Or is it just an incredibly clever pattern matcher? That distinction really matters, doesn't it? Especially when you rely on it for important stuff, sensitive conversations, where real understanding is critical.
It matters a lot.
Okay, language is one incredibly complex human system. But what about creativity? Art, writing, that feels so uniquely human, tied to emotion, experience, that spark of genius. How did AI even begin to make inroads there?
It's pretty mind-bending, isn't it?
Yeah.
AI venturing into this area that many people thought was, fundamentally off limits for machines.
Yeah.
And it immediately raises the question, what happens when creativity itself becomes something you can compute? How does that change our definition of art, of authorship? We really saw generative AI that creates new things emerge in a big way around this time for both text and images. OpenAI's GPT-3, which came out in 2021, and then GPT 3.5 powering ChatGPT in late 2022. These things showed abilities nobody really expected. They weren't explicitly programmed to write stories or poems or essays or code, but they could. And often as co-intelligence notes, remarkably close to human level on standard tests. It was a genuine shock to the system for many.
I remember that ChatGPT moment. It felt like something fundamental shifted almost overnight. It wasn't just understanding language anymore. It was generating it in this eerily fluent way.
It absolutely felt like that. And
Yeah.
to show the speed of progress, co-intelligence gives this funny example of an early GPT-3 trying to write a limerick. There was an AI named Charlie, and the source just says it was terrible in every way that matters. Didn't rhyme, wasn't funny, just bad.
Okay.
Contrast that with later models that could whip up witty, coherent verse. At the same time, you had AI art tools emerging that could quickly generate fake photographs that seem entirely plausible. Suddenly, anyone could create photorealistic images from text prompts.
Which is amazing creatively, but also scary. The potential for deception.
Both, definitely. It opened up amazing new creative avenues, letting people visualize things they couldn't before. But it also made widespread digital deception, deepfakes, fake news images terrifyingly easy, even for amateurs. And the key to this stunning leapfrog, as the source calls it, scale. Just massive amounts of data and computing power thrown at these models by places like OpenAI. They didn't just have slightly better algorithms, they had access to unprecedented training material, letting the models learn incredibly subtle patterns of human language and visual style. It felt like more than just an incremental step. It felt like a difference in kind.
But that also brought those immediate worries, right? Deepfake videos, scams using AI-generated voices.
Instantly. Co-intelligence mentions concerns about AI-emulated loved ones used in scams. The ability to generate such convincing fakes raised huge ethical red flags about truth and trust online.
So if AI can generate art, write stories, what does that mean for human creators? Does our role change? Are we becoming obsolete or just different?
That's the million-dollar question, isn't it? And this is where the idea of the human role becomes so important. Co-intelligence makes this really interesting point. AI is, quote, trained on vast swaths of humanity's cultural heritage. So maybe it's most effectively used by people who actually know that heritage deeply. They even provocatively suggest that humanities majors can produce some of the most interesting code for these systems.
Because they understand nuance, narrative, artistic intent.
Exactly. They know how to describe the effects they want. The role of the human prompter, the person guiding the AI, becomes absolutely critical. Think about a writer using AI. They can go beyond simple instructions. They can say things like, end this scene on an ominous note or make the tone increasingly frantic. They know how to shape the output.
And edit it, presumably. Refine it.
Definitely. Editing the AI's output, giving iterative feedback, experimenting with different styles, make this sound like The New Yorker, or do this in the style of Joan Didion. It suggests that AI, for now at least, is acting as a powerful co-intelligence. It's amplifying human expertise and judgment, not replacing it entirely. It's more like a collaboration, a very sophisticated tool that needs a skilled human operator.
A shift from direct creation to maybe curation and direction.
That seems to be a big part of it. It demands a different kind of human skill.
So for you listening, if AI can make art, write poems, what does that mean? Does it devalue human creativity? Or is it a new tool, like the camera was for painting, that demands new skills? Maybe a deeper understanding of culture, a better ability to prompt, to curate. It really makes you rethink what creativity is.
It really does.
Okay, so we've seen AI transforming medicine, communication, even art. It was clearly spreading fast. What other areas saw major disruption? And what did that teach us about the broader impact on society? It wasn't just a tech thing anymore.
No, definitely not. Zooming out, you see AI starting to touch almost every part of life. And that brings both these incredible possibilities and some really significant challenges. How we learn, how we move, how we work. And it forces this big question. How do we balance all this rapid technological change with, societal stability, with human well-being?
Right, managing the disruption.
Yeah, exactly.
Yeah.
Take education. The potential there is just enormous. Think about AI-powered virtual tutors. The promise is personalized attention for every student, adapting the teaching style, the content, the homework, all to fit an individual's pace, how engaged they are, what they specifically need help with. Brave New Words suggests it can even help with group projects, improve assessments beyond just standardized tests.
That sounds revolutionary compared to the traditional classroom, right? One teacher, 30 kids, all learning the same thing at the same speed.
Totally different. AI 2041 paints this picture of an AI tutor noticing tiny cues, like if a student's pupils dilate or their eyelids droop, to figure out the best way to teach that specific student geometry, even if that method doesn't work for others. Or imagine a kid loves basketball. The AI could rewrite math problems using natural language processing to be all about basketball stats, make it more engaging, more relevant.
We're seeing practical examples too, right? Like Conmigo?
Yeah, Conmigo from Khan Academy is a great example. It tries to mimic a human tutor, asks follow-up questions, checks if you really understood, suggests exercises based on how you're doing. It adapts. This hyper-personalized approach could make learning much more effective, engaging, and fun. There's talk of a potential 2 sigma improvement. That's a huge gain in educational outcomes, potentially closing achievement gaps. AI might even measure things we always thought were immeasurable, like creativity or curiosity. But
There's always a but.
always. Concerns about more screen time, kids using AI to cheat on homework, potential bias baked into the AI assessments. These are real issues.
And it doesn't replace human teachers entirely.
No way. The sources emphasize that human teachers, parents, mentors are still crucial. AI isn't replicating their full impact anytime soon. The insight is, AI can be an amazing tool for learning, but it needs careful human guidance and strong ethical oversight.
Okay, another area with huge potential but also huge risks. Autonomous vehicles. Self-driving cars. How did AI play into that and what were the hurdles?
Right, AVs, a classic example of high promise, high peril. Governments everywhere want to approve them once they're proven safer than people. Imagine dramatically cutting down those 1.35 million road deaths globally each year. That's huge. Plus, think of the time saved. AI 2041 estimates Americans could get back 8.5 hours a week on average. Car interiors could become offices, lounges, bedrooms.
Commuting time becomes useful time.
Exactly. But getting there is incredibly tricky. AI 2041 mentions these super detailed simulations they run, virtual models of cars tested endlessly. But prediction machines points out the core dilemma, especially for companies like Tesla. To make the AI driver better, you need real-world driving data, lots of it.
Data from cars actually driving themselves on public roads.
Yes, but that means putting a relatively young and inexperienced driver, the AI, in the hands of actual customers, out in the wild. And that inevitably risks lives.
That's a massive ethical tightrope. You need the data to improve safety, but getting the data involves risk now. The classic AI in the wild problem.
It's the perfect example. The stakes are so high. A mistake isn't just a bad email prediction. It's potentially fatal. So you have this trade-off. Deploy early, learn faster, but risk accidents, bad press, lawsuits, or, wait, improve it more in simulations, but slow down the learning curve significantly.
And there's no easy answer.
No clear answer. The optimal balance is really murky. It highlights how that rapid feedback loop that usually makes AI better becomes incredibly complex when safety is paramount. Real-world deployment has to be much slower, much more cautious.
And what about work? The impact on jobs, that's always a huge concern with automation.
Absolutely, and it started becoming very real in this period. AI can do many tasks better, faster, cheaper. essentially zero cost
Yeah.
for the task itself, as AI 2041 puts it. That raised fears of unprecedented job displacement, hitting both blue-collar and white-collar jobs. But it's not that simple. It's not just jobs disappearing.
You mean the automation paradox, where automation sometimes creates more jobs?
Exactly. That's a key concept.
Yeah.
Like with ATMs, they automated some teller tasks, but made running bank branches cheaper. So banks opened more branches and ended up hiring more tellers overall, just doing slightly different, more customer-focused tasks. AI Snake Oil mentions this.
So it's more about jobs changing than just vanishing, a redistribution.
It's definitely a massive reshaping. The sources talk about ghost work, this huge hidden workforce, often low-paid global workers, labeling data, training AI, doing the tasks the AI can't do yet. That underpins the whole thing. And there's the automation's last mile idea. Robots might move shelves in a warehouse, but humans still do the tricky part, picking diverse items off the shelf. Grasping is still hard for robots.
So automation creates new tasks, even as it eliminates old ones.
Right. Think about an office assistant. 50 years ago, maybe they were filing papers. Now they're troubleshooting laptops, managing cloud software, maybe using AI tools themselves. The job duties fundamentally change. AI creates this jagged frontier. Some tasks get automated, others don't. Workers increasingly need to specialize, become the expert human in the loop, complementing the AI. And sometimes just one small task in a whole job process proves impossible to automate. That missing link can prevent the whole job from being automated. Humans remain essential for knitting it all together. The big insight. AI doesn't just replace work, it redefines it, demanding constant adaptation from us.
Okay, this paints a picture of incredible power, rapid change across so many areas. But you mentioned the messy side earlier, the failures, the limitations. What challenges really surfaced when AI left the controlled environment of the lab?
This is crucial because as AI hit the real world, its limitations became much clearer, sometimes painfully so. And it forces that question. Are we sometimes too eager to adopt these things before we fully grasp how they work or don't work, especially in critical situations? This is where you get into the problem of what some critics call AI snake oil.
Snake oil, meaning exaggerated claims, hype.
Exactly. AI snake oil, the source, defines it as overstating what AI can do and downplaying its limitations. And here's the tricky part. Even critics can accidentally fuel this through what's called criti-hype.
Hmm.
By painting AI as this all-powerful, maybe even existential threat, they can inadvertently make it seem more capable than it is, which paradoxically might help companies avoid scrutiny for the actual current problems.
So that's a weird feedback loop. Exaggerated claims, even critical ones, make it harder to see the reality.
It can, yeah. It creates this cycle where marketing hype, maybe amplified by fear, leads to public misunderstanding. People don't evaluate it critically. Think about ChatGPT. OpenAI's blog talks about planning for AGI, artificial general intelligence, but Sam Altman himself tweeted that ChatGPT is incredibly limited, especially on truthfulness.
Mixed messages.
Totally. And then the website highlights how GPT-4 aces the bar exam. It's confusing. When people get caught up in this critics hype, they're much less likely to spot and challenge AI snake oil. It distracts from the immediate harms. Even the term hallucinations is a bit misleading, right? It sounds like a temporary glitch, an aberration.
But you're saying it's more fundamental.
Exactly. This brings us to that core challenge, AI hallucinations. Generative AI models frequently make stuff up, produce info that's just wrong or nonsensical. And crucially, as sources like Empire of AI stress, this isn't a bug to be fixed. It's an inherent feature of the probabilistic pattern matching mechanics. These models predict the next most likely word, statistically. They aren't built for factual accuracy.
It's a consequence of how they work, not a mistake in the code. I remember hearing about a lawyer who got in serious trouble for this.
Oh yeah, that was a high-profile case. Lawyer used ChatGPT for legal research. The chatbot completely fabricated case law, bogus judicial decisions with bogus quotes and bogus internal citations. Just made them up.
Wow. And the lawyer submitted them.
Submitted them to the court, got sanctioned, fined, huge public embarrassment. It starkly shows the danger, especially in high-stakes areas, law, medicine, finance, where accuracy is non-negotiable. Researchers are trying to mitigate it, sure, pointing models towards better data, using other techniques, but it's hard to predict every possible prompt, every weird output, especially as these models get bigger and more complex, almost like black boxes even to their developers.
Beyond just making things up, what about reflecting bad things from the real world? Bias.
Huge issue. Pervasive bias. AI models learn from vast amounts of data, right? And that data reflects existing societal biases. So the AI learns them too and can even amplify them. Think about that ghost work. Again, the people labeling data, often from specific demographics, potentially embedding their own conscious or unconscious biases right into the training set from day one.
Can you give a specific example of where this bias showed up in a deployed system?
Sure. Project Maven, the military AI for drone footage analysis. If the training data or algorithms are biased, you risk bias targeting. That's incredibly serious. Or look at the gender shades study. It found commercial facial recognition systems were way less accurate for women with darker skin tones, clear intersectional bias reflecting poor training data for certain groups. That led to a government audit.
And the Amazon hiring tool.
Right, Amazon had to scrap an AI recruiting tool because it learned to discriminate against women. It was trained on historical hiring data, which was mostly male, so it started penalizing resumes with terms like women's college. These aren't isolated incidents. They show AI isn't neutral. It reflects our biases. Even the way AI is trained with rewards, if you're not careful, can lead it to pursue immoral outcomes if the reward system isn't perfectly designed. And of course, there's the documented use by authoritarian regimes for surveillance, controlling populations. AI is a tool, and it can be used for harmful ends.
Tied into this, there's the way we react to AI, right? Treating it like it's human, anthropomorphism.
Yes, that's another subtle but important concern. AIs are often deliberately designed to seem human, empathetic. Co-intelligence and these strange new minds talk about this. It raises ethical questions about deception, emotional manipulation. We tend to casually act as if AI is a human, maybe oversharing personal info, forgetting we're talking to a corporate algorithm, not a person.
Our natural tendency to connect makes us vulnerable.
It can. If we forget these models aren't people, that they might have hidden goals, maximizing engagement for the company, collecting data we could be manipulated, especially with personalized AI designed to mimic relationships. The more human-like they seem, the more critical we need to be about their actual nature and motivations.
Okay, and finally, we have to touch on the really big one, AGI, artificial general intelligence. The idea of AI becoming super intelligent, maybe even an existential threat. How do the sources frame that debate?
It's a really divisive topic in the AI world. You've got one camp arguing AGI is this imminent existential threat needing urgent global action. Then you have others saying, whoa, slow down. It's a long-term prospect. We have time. We have tools to manage the risks. The whole AI safety community is grappling with, when might we get there? What will it look like? How can we steer it beneficially? But there's zero consensus.
This is where you hear the doom talk, right? People estimating the probability of AI causing human extinction. Even figures like Hinton expressing deep concerns.
It's exactly. Jeffrey Hinton, leaving Google in 2023, warning that humanity might just be a passing phase in intelligence evolution that got a lot of attention. Nick Bostrom's book, Superintelligence, fueled both fears, the famous paperclip maximizer scenario.
Where AI destroys the world trying to make paperclips?
Right, optimizing a simple goal with catastrophic consequences. But Bostrom also discussed utopian possibilities. Some researchers do literally state their personal probability estimate of extinction from AI. It reflects real anxiety in parts of the field. But again, we need to stay neutral here. The sources generally suggest there is no theoretical reason why this can't happen, but also no reason to suspect that it might happen soon.
So experts disagree strongly.
Wildly. World experts argue both sides. And a key point from critical sources like AI snake oil is that focusing too much on these far-off existential risks can be another form of criti-hype. It can overstate AI's current abilities, make it seem almost magical, and distract us from tackling the very real, immediate harms we've already talked about: bias, hallucinations, job impacts that need attention now. The AGI debate is important, but complex, often speculative, and shouldn't overshadow present-day realities.
Right. So bringing this all together, we've covered a lot of ground, from deep learning's breakout to its impact on medicine, language, art, work, and then confronting these very real limitations and risks. What's the big takeaway for us?
Well, stepping back, that move out of the lab in the mid-2010s, that was undeniably a profound shift. But it's not about machines becoming sentient overlords, not really. It's more about understanding AI as this powerful, maybe slightly alien co-intelligence. It can do incredible things in specific areas, predict drug interactions, write poetry, help teach kids. But our deep dive shows it's also deeply flawed, prone to making things up, reflecting our own biases, because it learns from our data, our world.
So the magic isn't really magic, it's engineering. complex, impressive, but ultimately understandable
All right.
and fallible.
Exactly. As Empire AI puts it, the magic kind of dissolves when you explain how it works. You see, it's a collection of procedures, algorithms. Clever, yes, but understandable. It's not some mysterious consciousness. It's computation that needs careful design, constant oversight, and a very clear-eyed view of its limits and the biases it carries. The real takeaway, AI is like a mirror. It reflects our brilliance, yes, but also our flaws, our biases, our blind spots.
So, the final thought for you, our listener, as AI keeps advancing, creating huge wealth, shaking up society, how do we make sure we guide it constructively? How do we use it to expand opportunity for everyone and nurturing human potential, as one source puts it, instead of just letting fear or hype take over? What kind of human skills, judgment, empathy, critical thinking become even more vital in a world where AI is everywhere and it's getting harder and harder to tell what's real and what's generated? That's something definitely worth thinking about.